The law of conservation of energy states, the total energy of an object remains constant if no external forces other than weight have done any work on it. A block of 2 kg starts from rest on a smooth slope inclined at 30 degrees to the horizontal and slides down 2 meters. We can see there's only weight W, and normal reaction R, acting on the block. Resolve W and use Newton's second law of motion, we can get the block's acceleration as g sine 30, which is 5 meters per second square. U is 0. S is 2 meters. Using the formula, v squared equals u squared plus 2as, we get, v squared is 20. We can see only weight has done work. R is perpendicular to v, so it does no work. In the initial state, Pe is mgh, which is 20 joule. Ke is 0. The total energy is 20 joule. In the final state, Pe is 0. Ke is half mv squared, which is 20 joule. So the total energy is also 20 joule. It's unchanged. Notice, the shape in which the block travels doesn't matter. For example, a ball of 2 kg slides from rest, along this smooth track. The height difference between the two ends is 3 meters. Find its speed at the end of the track. Similar to the previous case, only weight has done work to the ball. The track is smooth, so there's no friction. And normal reaction is always perpendicular to the velocity, so it has done no work. Therefore, the initial energy is equal to the final energy. Initial energy is only Pe, which is mgh. Final energy is only Ke, which is half mv squared. Therefore, V is root 2 gh, which is root 60, or 7.75 meters per second. We know from the law of conservation of energy, if only weight has done work, Pe1 plus Ke1 equals Pe2 plus Ke2. Move terms around, we have, Pe2 minus Pe1 plus Ke2 minus Ke1 is 0. Pe2 minus Pe1 is delta Pe. Ke2 minus Ke1 is delta Ke. So if only weight has done work, delta Pe plus delta Ke is 0. Delta Pe is minus delta Ke. Gain in Pe is loss in Ke. Loss in Pe is gain in Ke. If a ball rises h meters, work done by weight is minus mgh, because weight and displacement are opposite directions. Delta P is mgh, because it rises h meters. So work done by weight is minus delta Pe. According to work energy principle, work done by all forces is equal to change in kinetic energy. Work done by all forces can be written into work done by weight plus work done by other forces. Work done by weight is minus delta Pe. So, minus delta Pe plus work done by other forces is delta Ke. Therefore, work energy principle can be also expressed by work done by forces other than weight is equal to change in potential and kinetic energy. Sigma W other equals delta Pe plus delta Ke. The diagram shows the vertical cross-section ABC of a fixed surface. AB is a curve and BC is a horizontal straight line. The part of the surface containing AB is smooth and the part containing BC is rough. A is at a height of 1.8 meters above BC. A particle of mass half a kilogram is released from rest at A and travels along the surface to C. 1. Find the speed of the particle at B. 2. Given that the particle reaches C with a speed of 5 meters per second, find the work done against the resistance to motion as the particle moves from B to C. From A to B, only weight has done work. So energy is conserved. mgh is half mv squared. Therefore, V is root 2 gh, which is 6 meters per second. From B to C, there's no change in PE. We know sigma W other is delta PE plus delta KE. Delta PE is 0. Delta KE is negative. So work done against resistance is decrease in KE. It is half m6 squared minus 5 squared, which is 2.75 joule. A block of mass 20 kilograms is pulled from the bottom to the top of a slope. The slope has length 10 meters and is inclined at 4.5 degrees to the horizontal. The speed of the block is 2.5 meters per second at the bottom of the slope and 1.5 meters per second at the top of the slope. 1. Find the loss of kinetic energy and the gain in potential energy of the block. Loss of Ke is half times 20 times 2.5 squared minus 1.5 squared, which is 40 joule. Gain in PE is 20 times 10 sine 4.5 degrees, which is 156.92 joule. Two. Given that the work done against the resistance to motion is 50 joule, find the work done by the pulling force acting on the block. Sigma W other is delta PE plus delta KE. Work done by other forces is W minus 50. From 1, delta PE plus delta KE is 156.92 minus 40. So W is 166.92 joule. 3. Given also that the pulling force is constant and acts at an angle of 15 degrees upwards from the slope, find its magnitude. Work is Fs cosine 15 degrees. So F times 10 times cosine 15 degrees is 166.92. F is 17.3 Newton. In this class, we learned: if only weight has done work, PE1 plus KE1 equals PE2 plus KE2. It can also be written as, delta PE plus delta KE is 0. Work energy principle can be also expressed as, work done by all forces other than weight is the total change in potential energy and kinetic energy.